This is my 8th video in my series on doing inferential statistics with Google Sheets by simulations, and the 4th and little mini-series with this paired numerical data. In the first of this little mini-series, we took this June 2018 survey, and we looked at the 2 columns of what people think the tax rate is on people making over $500,000 a year and what they think it should be. And we asked, are those 2 numbers actually different? Some people think it's high but think it should be lower. Some people think it's low but think it should be higher. Is there actually a pattern to that? We scrubbed the data, removed the answers that don't make any sense. We then did some simulations. We determined the actual difference in the average is 1.5%. And we did some simulations. We randomly swapped people's responses. That's called a paired samples t-test. We're not completely randomizing them. We're just randomly swapping some people's responses. And every time I do that, as you can see, all these formulas we have in place, re-randomize the 2 averages. I can see what the difference is, and I can see whether I can get a difference of 1.5% just with randomness, and I can't. In all of these trials, I'm failing to get a difference of at least 1.5%. Now we're going to back that up mathematically. We're going to actually run a paired samples t-test to find the p-value. And pretty simple on Google Sheets, I'm going to type equals t-test, open parentheses. First, I'm going to do column A as my first variable, A2 colon A440, comma, A440, I forgot the A, that's going to mess things up. Now I'm going to do B2 colon B440. As we always do, this will be a 2-tailed t-test. I'm going to type a 2. Then I have a choice of 3 different types, and if I forget which one is which, I just click on this here, and it reminds me that the paired samples t-test, where I'm assuming that each 2 numbers stay with the same person, I just maybe do or do not swap them. The paired samples t-test is type 1. It tells me that right here. So I'm going to type a 1 at the end there, close parentheses, enter, and I can see I have a p-value of about 2%. So I'd expect about 1 time in 50 for me to be able to generate a difference of 1.5 just using randomness. Randomness is not quite enough to explain this difference of 1.5, but 2% of the time it can.